Today we are going to continue our discussion on the scientific method. We talked just the other day about the steps in the scientific method. We said that you question, that you make a hypothesis, that you make an experiment to test your hypothesis, that you make observations, you are going to analyze your data that you generate and draw a conclusion. I'm going to talk about what each one of these words means. We are going to define the terms. And then we are going to have an example. All right. What is a question? A question is a statement that you make, a statement about gaining knowledge. We want to know, why is the sun so hot? So we're going to ask a question. Why is the sun so hot? So a question is a statement that you make because you want to gain knowledge about something. Our real world example is going to be what will the middle school schedule look like? With 5 classes. Because this is different than how it was last year. New class, new schedule. What is that going to look like? Once you've asked a question, the next step is to form a hypothesis. A hypothesis is a potential answer. It's your best guess about what the answer to the question is. Hypotheses come in 3 flavors. You have your basic hypothesis. You step outside, you look up at the sky, you think, oh, I hypothesize that it's going to rain today because it's cloudy. That's your best guess about what's going to happen. The next level up from a hypothesis is called a theory. Most people use the word theory and hypothesis interchangeably. They are wrong. A theory is a hypothesis that has been tested. Many, many times. Many, many times. Many, 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 many times. And shown to be true. So, some of our friends, I asked, who can tell me a theory? And they said, oh, the Big Bang is a theory. That is a hypothesis about the beginning of the universe, which has been tested many, 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 many times. It's graduated to be a theory. Above a theory, the next level of hypothesis is a law. Law is a very strong word. You know, you can't break it. It's a rule that cannot be broken. And in this case, a law is a theory or hypothesis that is true under every circumstance. Can't spell today. E-V-E-R-Y. Under every circumstance. Ever. It is a theory that has been proven to be true over and over and over and over and over and over again. The laws that we know about, the laws of planetary motion. Newton's laws of motion. Gravity is a law, not a theory. So a hypothesis is a potential idea, a potential answer. A theory is a hypothesis that has been tested over and over again and shown to be true. A law is a theory that is true under every circumstance ever. What was our hypothesis about the middle school schedule? Well, our hypothesis was that the schedule is awesome. Dare I say, perfect. And that it was going to be just like being in school. In person. How are we going to see if we were right? Well, we're going to do an experiment. An experiment is an ordered investigation so I'm going to take an ordered series of steps to prove or disprove the hypothesis. What kind of experiment are we going to do? Well, we're going to hand out that schedule and use it for a couple of weeks. And when we hand out the schedule to be used for a few weeks, we're going to make some observations. An observation is gaining knowledge by using our senses. Sometimes, by making observations, we figure out facts. A fact is an observation that has been confirmed many times. It's been confirmed so many times that we say it is true. A fact is an observation that has been made so many times that we say it is true. What kind of observations were made about our schedule? I know I, for one, am exhausted. I told the kids I'm so tired that I go home and I go to sleep at night and I dream that I am exhausted. Some of our friends felt that it was a little chaotic, switching from one Zoom to another, that there were a lot of tech issues and anxiety. I would agree. The next step is to analyze your observations. To analyze your observations, you need to compare your expected results to your actual results. I need to look at what I wanted to have happen, and did that actually happen? And my analysis, not so good. My expected results were that everything was going to be great. The actual results, not so much. So our conclusion that we can make from our experiments, our conclusion is a statement as to, it's a statement about the truth of the hypothesis. It's a statement as to whether or not my hypothesis is true. My conclusion, a lot of folks' conclusion about the schedule, is that the schedule is going to need to change. Did the conclusion match my hypothesis? No. In fact, it proved what is called the null hypothesis. Not that the hypothesis was wrong, but that something else was in fact true. And what it ends up doing is generating another question. So now I'm going to ask a new question. I'm going to generate a new hypothesis. I'm going to do a new experiment. I'm going to make new observations. I'm going to do a new analysis and generate a new conclusion, and I'm going to repeat as often as necessary. So I'm going to repeat as often as needed. Now, I used a very unscientific example because I wanted you guys to see that the scientific method actually applies to so many different aspects of your everyday life. Whether you realize it or not, you're asking a question, you're coming up with an idea, you're testing to see if that idea is true, You're making observations and decisions, and then maybe generating a new question. That is the scientific method.